Hello everybody, welcome to Chem 410 at the University of Toronto. My name's Andrew and I'll be a TA for the course. This is going to be a short video on how to do some dilutions with an internal standard in them. This is kind of a tricky subject, so don't worry if it takes you some trials to get through it. However, there's a couple of key bases that you need to keep in mind when you're doing any of these, which I'll cover throughout the video. Hope you enjoy. So one of the overall important concepts that you need to keep in mind is that in our vial, our sample vial that we have here, we need to keep the ratio of our solvents equal to the ratio that we'll be using for our LCMS, which in this case is 50-50 methanol to water. For this video, we're going to use 1 milliliter as a total volume for all of our calculations. You can see this tick mark on the side of the LC vials that you'll have, but it's best to not use that as your measure rather than actually using your pipettes or volumetric flasks, because they are much more reliable than the printed numbers. Your best friend for all of these calculations is going to be the handy C1V1 equals C2V2. This will be the catch-all for any of these dilutions calculations. So since we're using 1 milliliter or 100 microliters as our final volume, V2, and we know that C2 will be the dilution that we would like. For in this case, we're going to do a 10 times dilution. So 1 over 10 or 0.1. And then we can assume that our initial concentration is, let's say, 1 part per billion, for example, or 1 part per million. Does not matter. And we need to find how much of the C1 we need to get to C2. So, simple algebra, you can just isolate for our unknown, for our V1, and that ends up being 100 microliters. So 100 microliters in a total of 1,000 microliters will give us a 10 times dilution. This will hold true for 3 times dilution, 2.5 times dilution, etc. Now we know how much of our standard or sample we need to add. We still need to figure out how much filling to volume we need. Like I said in the previous thing, we need to make sure we have 50% methanol and 50% water. However, our samples are all in methanol, so this uses part of that 500 microliters that we need. So we know that we need to add our 25 microliters of internal standard, as is outlined in the lab manual. We just calculated that we need 100 microliters of our sample to get a 10 times dilution. However, that with the 500 microliters of water does not give us our 1 mil. So we just subtract and we can find that we need 375 microliters of clean methanol. That, with our internal standard and sample, will give us our 500 microliters of methanol, which will give us our 50-50 ratio of methanol to water for our final LC vial that's ready to analyze. Now that we know the volume of everything that we need to add, we can go about adding them. First is easiest to add the 500 microliters of water. Then the order of the following additions don't matter quite as much. However, this is just a graphic to kind of show you how the internal standard, the sample extract, and the clean methanol will all add up to that 500 microliters of methanol to keep the 50-50 ratio ready for analysis. Then once everything's added, you can just vortex that little sample vial, make sure everything is fully homogenized, and you're ready to go. So hopefully that was helpful demonstrating how dilutions with internal standards can be gone about. If you have any other questions, feel free to contact your TA or lab supervisor, and hopefully this was helpful. Thanks for listening.